Hello, everyone. My name is Slava Tykhonov, and I'm from DANS, institution from KNAW, Dutch Royal Academy of Arts and Sciences. And it's my pleasure to introduce you distributed open science data infrastructure that we are building for Dataverse community. So a few words about me. I used to work on a lot of data infrastructures, both national and international. And currently I'm involved in a lot of projects. So here you can see the list. And if you want to know more, you can always follow me on LinkedIn. I'm also Harvard Dataverse Ambassador in Europe. And in further slides, I will tell you something about Dataverse. So what is Dataverse? It's open source project developed by Harvard IQSS, and it's published on GitHub, and it's data repository. And it's a great product with long history, starting from 2006 with the dynamic and experienced development team working in agile environment. And it has clear vision and understanding of research community's requirements, and really international community behind of Dataverse is helping to improve the basic functionality and develop it further. So we are part of it. Our institution is one of main contributors to Dataverse, and is being used by a lot of countries from all continents, and also it allows to develop external applications based on API endpoints available in Dataverse. So our vision, what we want to implement is semantic interoperability on infrastructure level. So we envision the situation where thousands of Dataverse instances, due to the development of European open science cloud and other initiatives, it will be available and accessible for search of data and will form common data layer. So the old dream of federated search and universal catalog can be realized as two different goals. First goal is to provide crosswalks and mappings across different metadata schemas. And second, in metadata schemas, we seek for ways to enrich indexes with values from control vocabularies. So we have basically two different situations. One is traditional with standard response, it's centralized. So the idea that we'll run one data repository and we will try to collect data from different disciplines and probably from different institutions. And in second situation, we are going to run a distributed infrastructure, which means that every institution will run own data repository, and after it will be linked together by semantic web technologies. So we're going to produce linked data, and it could be considered as a common data infrastructure. So our future data services are highly related to our projects. So we are doing projects with different communities. And here in this picture, you see that we have archaeological community involved, we have humanities, we have social sciences, we have genetic community. So basically, we are collecting requirements from every community and building common infrastructure. And Dataverse is our key framework for open innovation. So how we are going to do that? We are using Harvard Data Commons, and it means that in our infrastructure, we have research tools integrated with data repository, we have computing resources, and we have storage. So we have the complete infrastructure that can be deployed for any kind of community, and it just runs as a common layer, data layer. So we are able to provide this infrastructure for different teams, for different projects, and there is also possibility to organize international collaboration between those teams. But still, it's just possibility to use the same horizontal platform built on Dataverse to serve vertical teams. So on this picture, you can see how it could be organized if you have some pipelines such as natural language processing and machine learning. And our contribution to Dataverse, our recent contribution related to external control vocabularies, is really pointing and driving Dataverse in semantic web direction. what we implemented is possibility to look up for concepts, for keywords, and you can see there is a pop-up list with a lot of keywords that could be selected. And as soon as they are selected, there is also concept URI is being stored and linked to metadata record. So we are able to connect any kind of control vocabularies in fair way with URIs. And even greater vision on this picture, using this approach, we're building a knowledge graph. So all our metadata is ingested in knowledge graph, and we're using SKOS, the simple knowledge organization system, to keep all relationships between all concepts. And this is really powerful mechanism because we can actually link metadata coming from different disciplines in the same knowledge graph. And this is how we can organize data delivery to any community connected to us. So once in knowledge graph, what can we do next? In this example, our pipeline is just getting data set from Harvard Dataverse, and it's been enriched with links to Wikidata. So we're getting automatically linked concepts coming from Wikidata records, and this is how we can get a lot of URLs and URIs from Wikidata. And as probably you know, Wikidata has a lot of language properties supported, so we can find information even if we are searching in other languages. So this is really a cool and excellent mechanism to build semantic search. So future direction in which we are moving is related to artificial intelligence and machine learning. At the moment, Dataverse network has more than 300 datasets described in various languages with different quality of metadata. And question here, how do we extract knowledge and link concepts from all datasets available in our network, and how we will build this knowledge graph using this information. So human resources are very expensive, so this is why we decided to build AI and ML pipelines for automated metadata enrichment and linkage prediction, and we're applying named entity recognition and natural language processing algorithms for data mining and doing topic classification and other stuff. So basically, we are creating human-readable annotations that could be used to build and retrain machine learning models, and always these multidisciplinary knowledge graphs that we are building, facilitating the development of new projects with economic and social scientists, both on national level and also international. So this is how it looks like, community-driven annotation. All of concepts were extracted by artificial intelligence, and as soon as there are some mistakes in this annotation, we have a help of experts. They can just correct this, and after model will be retrained, and next time it will do better recognition. So as a next step, there is a limitation with current persistent identifiers. As probably you know, DIs and handles, they're mostly used for datasets. So we are going to extend it to support other types of data, for example, audiovisual materials. And for this reason, we are going to use decentralized identifiers, DIDs. And also it can help us to solve other kind of problems like concept drift and so on. So to summarize, benefits of using a common data infrastructure you can find on this slide. So all metadata standardized on infrastructure level because we're using the same data repository, and all data shared between different countries and continents in unified format, and maintenance costs drop massively as more organizations will join, and it will be less expensive to support. So this infrastructure is distributed and sustainable and really prepared for the future. And the use of same infrastructure components will enforce the quality and speed of knowledge exchange. So in a way, common data infrastructure plays a role of gravitational force for data science projects, and more people are joining community. So thank you very much. And you can follow me on Twitter, LinkedIn, if you want to get more information, or just contact me on this email. Thank you.